In this video, we're going to solve a polynomial equation by factoring a trinomial. So we're going to do something very similar here that we did when we used the greatest common factor to solve polynomial equations. We're going to use that zero product property. So notice that here, because we have an equal to 0, we're kind of close to being able to use the zero product property. But we need to have this product part as well. And that is where factored form comes in. Now, because this is a trinomial, we can't use the GCF strategy. We have to use something else. So because we have the trinomial here, in order to factor a trinomial, we need to use our ABC method. So that's what we're going to do here to write this into factored form. So I'm going to start by finding A, B, and C. And I notice here that A is my coefficient of n squared, which is 1. B is my coefficient of n, which is a -6. And C is my constant value by itself, which is 8. So here I found my A, B, and C values. So I need two numbers that multiply to A times C, which is 1 times 8. So I need two numbers that multiply to 8 and add to B, which is -6. So if I start thinking through the factors of 8 and what might multiply to 8 and add to -6, I eventually determined that -4 times -2 will give me a +8, but that those two numbers added together will give me a -6. So now what I'm going to do is I'm going to take this middle term and I'm going to rewrite it as -4n plus -2n. And then I bring down the 1n squared in front and add the 8 onto the end, along with the equals 0. So notice here that I've used that first step to help me at least split this up. Then I'm going to split it into two pairs and look for the GCF in each pair. Now in the first pair, the only thing that they each have in common is an n. They don't have a numerical factor other than 1. So if I factor an n out in front, I end up with just 1n. And then I have a -4 on the inside. So my goal is I create this second set of parentheses and I want to get 1n minus 4. So then from here, as I look, I notice that I have a -2 and an 8. And if I want to get it to match this parenthesis piece right here, I notice that I need to factor out a -2. So as I factor out a -2, I end up with -2 over -2, which is a 1n. Then I have plus 8 divided by -2 is -4. And then I still have my equals 0. So here, even though I have a subtraction in one and a plus a negative in the other, they're the exact same thing. Plus a negative and subtraction are the same thing. So then from here I notice that I have matching parenthesis parts. And because I have matching parenthesis parts, I can link this n and this -2 together. And I can say, well, both n and -2, both of them, are going to be multiplied by n minus 4, or 1n minus 4. And then I still have this equals 0 on the end. So notice here that I've used my knowledge of the ABC strategy to write this equation written in standard form and rewrite that polynomial into factored form. And now I have something times something is equal to 0, which is the zero product property. So now what I can do now that this is factored and it's something times something equals 0 is I can set each component equal to 0 and figure out which value for n will make it equal 0. So here we add 2 to each side, so we have n is equal to 2, or n is equal to 4. So those are my two values for n that will make my original equation true. So let's try a second example here. What I notice as I look at this example is that my equal sign is kind of in the middle of everything. And unfortunately, I don't have the 0 part to even start thinking about the zero product property. So what I need to do first is I need to rewrite this equation so that all terms are on the same side of the equal sign. So what I'm going to do is I'm going to move this 45 to the other side by adding 45 to each side. So now I have x squared plus 14x plus 45 is equal to 0. And now I have this 0 part of the zero product property. And now that I have them all on the same side, I'm ready to try factoring them so that I can get a product here. So I notice here that I have a trinomial because there are 3 parts, there are 3 monomials, and because I have a trinomial, I need to use the A, B, C method to factor. So I need to start by finding my A value, my B value, and my C value. And if I look here, I notice that my A value is this 1 out in front of the x squared. So A is 1, B is 14, and C is 45. So now that I have my coefficient of x squared x and my constant, I then need to find 2 numbers that multiply to A times C, which is 45, and add to B, which is 14. So I need 2 numbers that multiply to 45 and add to 14. And if I start thinking about the factors of 45 and what might multiply to be 45, I eventually discover that 9 times 5 will give me 45, and that added together, those will give me 14. So what I'm going to do is I'm going to rewrite 14 as 9x plus 5x, and then I'm going to bring down the rest of the problem. So I have 1x squared plus 9x plus 5x plus 45 is equal to 0. And then from here, I'm going to split these up into pairs and look for the greatest common factor. So in that first chunk, the greatest common factor is 1. And then from there, it would just be an x, so I can factor out an x. And in the second one, it would be 5x and 45, which the greatest common factor is 5. So if I factor those out, I end up with x times x plus 9 plus 5 times x plus 9, and then my equals 0 is tacked on to the end. And what I'm noticing here is, just as I expected, my 2 parenthesis pieces match. Both x and 5 are being multiplied by x plus 9. So we can group them together and say both x and 5 are being multiplied by x plus 9. And then from here, I can finally see that I have the zero product property. I have something times something is equal to 0. Zero product property. So what I can do with these is I can set each component equal to 0. So I have x plus 5 could be equal to 0, or x plus 9 could be equal to 0. So I subtract 5 from each side, and I find that x could equal negative 5. Or if I subtract 9 from each side, I find x could also equal a negative 9. So now let's take things one step further. This one, again, we notice that all the items are not on the same side of the equal sign, so we need to move that 12d over. So we have minus 12d on each side. And now where this gets tricky is I know that I need to write these in descending order. The order in which I write them matters. So I know that my d squared is the largest degree. So I'm going to write 4d squared plus my next largest degree is just the d, so that negative 12d goes actually in the middle. And then I have that negative 7 left. So be very, very careful. It goes variable squared, and then the variable, and then the number part, just with the number, comes last. So then from here, I can start then, because I have the 0 part of the zero product property, I can start working on writing it into factored form. So I start by finding a, b, and c, which a is the coefficient of d squared, which is 4, b is the coefficient of d, which is negative 12, and c is just the constant at the end, which is negative 7. So I need 2 numbers that multiply to a times c, which is 4 times 7, which is negative 28, and add to negative 12. So as I start thinking these through, I need 2 numbers that multiply to negative 28 and add to negative 12. And I think of those factors of negative 28, and I eventually discover that the two numbers that make this true are negative 14 and 2. When multiplied together, those two numbers give me negative 28, and when added together, those two numbers give me negative 12. So I'm going to rewrite this negative 12 as negative 14d plus 2d. And then I have 4d squared out in front, and negative 7 equals 0 on the back. Then I split these up into pairs. So I have 4d squared minus 14d, which I notice that they both contain a factor of 2, and they both contain at least one d. So I factor out a 2d, so then I have 4 divided by 2 is 2, with a d left over, minus 14 divided by 2 is 7, and that's it, the d's cancel. So then I look at the next pair, and I notice that these two don't have anything in common other than a factor of 1. So I still need to factor something out, and I want the parenthesis parts to match. And since their greatest common factor is literally just 1, here I'm just going to factor out 1. So I factor a 1 out of that, and it leaves me with 2d, and then I can write plus negative 7 or minus 7. But now that I've factored out that 1, I have a matching parenthesis part. So even though it seems kind of silly to factor out this 1, it will help you in the long run. So their greatest common factor is 1, so factor that out. Now that I have the matching parenthesis parts, I can group those coefficients together. So I have 2d plus 1. Both 2d and 1 are being multiplied by 2d minus 7. So then here, I can see that I have a product of two items being multiplied that equals 0. So, zero product property comes into play. So now I can set each part equal to 0. So, 2d plus 1 is equal to 0. So subtract 1, divide by 2. So one option is that d is equal to a negative 1/2. The other option, if I set 2d minus 7 equal to 0, we add 7, so you get 2d equals 7, divide by 2. The other option is d is equal to a positive 7 over 2. And final example here. So I've got a lot going on in this problem, but again, we always want to start by getting everything on the same side of the equation. So I'm going to start by subtracting 2x, and then by subtracting the 4 over, and combining it with its like term. So here I then have 6x squared plus, this is negative 1x, plus negative 2 is equal to 0. So I now have the 0 part of the zero product property. So I then move on to finding my a, b, and c values. So a is equal to 6, b is equal to negative 1, c is equal to negative 2. And then I need to find two numbers that multiply to a times c, which is 6 times negative 2, which is negative 12, and add to b, which is negative 1. So I start thinking through the factors of negative 12, what is going to multiply to negative 12, and I ultimately discover that if I take negative 4 times 3, that will multiply to negative 12, but will then also add to negative 1. So then I'm going to take my negative 1 here, and I'm going to split it into negative 4x plus 3x. And then I'll carry down the rest of the problem. And then from here I can split these into pairs. And I find their greatest common factor in pairs. So this first one, they're both divisible by 2, and they both contain an x. So we factor out 2x, and we get 3x minus 2. And then here again I notice that my greatest common factor between 3x and negative 2 is just 1. So I'm going to factor out a 1 and leave the 3x, you can write plus negative 2 or minus 2 on the inside. Then from here I notice that I have matching parenthesis parts, so I can group together those coefficients in front. So we have both 2x and 1 being multiplied by 3x minus 2. And then from here I notice that I have a product of two items equaling 0. So I can utilize the zero product property and set each part equal to 0. So we have 2x plus 1 equals 0, so we subtract 1, divide by 2, and we find that one option for x is that it equals a negative 1/2. And then we set the other piece equal to 0. We add 2 to each side, then divide by 3. We find the other option for x is that x is equal to 2/3. So we have negative 1/2 and 2/3. And then just to hit on this one last time, when do you factor versus when do you solve and actually find values for x? We factor when it's an expression, which means there is no equals sign. Essentially that means there's nothing to solve. There's no equal sign. All we can do is rewrite it in a different way. Whereas we actually solve as a result of an equal sign. So if we see an equal sign in a problem, that is something where we can solve and actually find variable values that will make the equation true.